Thank you everyone for coming to my talk. Today I'll be talking about Linkerd and some of the things that we learned when we deployed it in multiple cloud environments. You may find this talk useful if you actually run Linkerd in production, or if you're running any high concurrency JVM application in the cloud. But before we get into it, I'd like to share a little bit about myself, kind of loosen myself up. I am from a small southern African country called Botswana. Anyone know where that is? Nice, nice. But I was raised by my Ghanaian parents, and you may be asking, why am I sharing this? Well, I have this weird thing that if someone asks me where I'm from, depending on the day, depending on how I'm feeling, I'll either say I'm from Botswana or I'll say I'm from Ghana. So, and every time when they come back and ask me again, or I'm in a conversation, people get really confused because I say something different. So today, I'm not going to try and confuse everyone. I'm going to tell you that I'm from both countries. Hopefully that lessens the confusion. Anyways, I'm a software engineer at Buoyant, where I maintain Linkerd, the open source project. If you want to check out some of the cool things that we're doing with Linkerd and at Buoyant, or if you want to ask any questions, or if you want to send me memes, that's pretty much what I do on the times when I'm not working. I just look at memes. You can reach me on Twitter, or if you want to get these slides are on my GitHub page. My GitHub handle is right here. So what is Linkerd? How many people are using Linkerd in production? 2, 3, okay, good amount. So Linkerd is a service mesh that abstracts service-to-service communication into its own layer. And what that does is it provides you reliability, security, and visibility. And Linkerd is built on Finagle and Netty, so it's able to handle high amounts of concurrency, able to handle large request loads without breaking a sweat, with the caveat that you give it ample amount of resources. And that's pretty much what the whole talk is about, but we'll get into that. What's great about Linkerd is that it runs as a separate process, and so you don't have to include any libraries or any frameworks in your microservices code just to get some of the benefits that it gives you. So what does it give you? Well, right off the bat, it gives you service discovery integration. We currently support multiple service discovery backends. Thinking off the top of my head, we've got Console, we've got Marathon in Mesos, we've got Kubernetes, DNS, and many more. And what's great about Linkerd is that it allows you to extend functionality through its plugin system. All you have to do is just build a jar that conforms to Linkerd's service discovery interface, drop in that jar in its class path, and Linkerd is able to read that and apply that new functionality that you've created. So on top of service discovery, you also get load balancing. The load balancing algorithm we all know and love, round robin, but it also gives you additional load balancing algorithms that work off of observed latency. And this kind of helps tame your latency values across your percentiles. Other things you can do are configure retries, configure timeouts for those retries so that they don't happen forever. And Linkerd has this concept of delegation tables, or DTABs. And what this does is allows you to add more complex routing for your services so that you can do things like canary deployments or do blue-green deployments when you are running things in production. You've also got the security aspect of Linkerd, where you can apply TLS for your services, or you can apply TLS between Linkerd instances. So we've got all these features, but where did it all start? Well, it started in 2015, where we saw that Finagle was a viable option for programmers to build highly concurrent services and applications. And we really owe this to Scala because of its code expressiveness and its unique mix between functional programming and object-oriented programming. And on top of that, the fact that you can write Scala applications and then compile it down so that it runs on the bytecode, we get the benefits of the JVM and its interoperability and being able to move it wherever we need to move it in our environments. Fast forward to today, Linkerd has been in production in many companies for about 2-3 years. We have a very active community, lots of contributions we see come through there. And I've been working at Buoyant for a little over a year, and I've been really excited and energized by seeing all the work that's coming through it. Right now, Linkerd is servicing billions and billions of requests, which is kind of hard to imagine when you look at the dashboards, but it's pretty cool to see. And I'm really excited for where things go next. All right, so why are we talking about this? Well, over the 3 years, there's been one thing that we've been fighting, and that's memory, or memory usage. But why does that matter? Well, over the past 5 years, we've been seeing this migration from traditional architectures, like our 3-layered architectures, to the cloud. And it's natural for Linkerd, or Linkerd was designed purposely to accompany these microservices to run in the cloud. And the issue that we run into is that Linkerd is built on the JVM. The JVM is great. It's got a rich ecosystem, and it's designed to scale up very well and handle tons and tons of traffic. But when you want to do the opposite, or you want to scale things down, you have to do a great deal of work just to make that happen. So why do we want to do that? Well, when we designed Linkerd, it was designed to work as a sidecar, designed to work as a distributed proxy, where it runs along each and every one of your services so that you can kind of do the things that we all want, like the service discovery, the retries, and all that. With the sidecar approach, you have more finer-grained control of running your services and making changes to your services. But again, the memory usage is kind of a bottleneck. You can do a lot to bring this down to about 100 megabytes running on your system, but when you've got 100 plus services and you have to deploy this for each and every service, that's not going to fly. You end up having like a really huge cloud infrastructure bill, and people are not happy. So we kind of went back to the drawing board. We started thinking about, okay, so what can we do to mitigate this issue? So, all right, we'll deploy Linkerd deploy one instance of Linkerd for each host. And this is the per host deployment model that we recommend for anyone that is trying to use Linkerd. With this, you still get the service-to-service level kind of reliability, security, and all that. But this also has its disadvantages as well. Right off the bat, if you are really strict, or if you have really top security priorities, you can't really do mutual TLS, because you have to do TLS between your Linkerd instances. You can't do it from one service to the other. And then things like upgrading Linkerd become very difficult, where if you want to upgrade just one Linkerd instance that's running, you have to basically give up service routing for all the pods or all the containers that are running on one host. So what's it like to deploy Linkerd today? If you go to our GitHub page, get the executable, and then run it, this is kind of what you get. So in this example, I have Linkerd deployed in Kubernetes. This Kubernetes cluster has 3 nodes, so we've got one Linkerd instance for each node, and we can see we're almost reaching 400 megabytes of memory consumption. And this is at 1,000 requests per second. And so for the past 3 years, we're like, can we do better? Is this the status quo? Do we let people use this? And so we went on this journey to optimize Linkerd. And so here's an overview of kind of what we did. We did basically JVM tuning. We started to play around with different kinds of VMs. And then I'll talk about this last point a little later. So with the tuning, we started off with the JVM. We started messing with flags on the hotspot VM. Some of the things that we did were like tons of things that had to do with garbage collection. In JDK 8, we turned on concurrent mark sweep. We turned off tiered compilation. That helped a little bit, and we started just twisting knobs and tweaking things. And so once we had enough fun with that, we decided, okay, what else can we tweak? And so we started looking at Finagle. And it turns out Finagle has a lot of options that you can configure so that you can handle different types of load, handle different types of requests. And the ones that we worked with particularly where the thread was handling threads or settings for threads so that we could control concurrency. And also we configured memory used for each thread so that we could tame memory that Linkerd needed. And it turns out Netty also kind of has some of these settings. But after doing all this, we found that there was no magic configuration, no magical set of parameters that would make Linkerd run perfectly for everyone. Because depending on your system, depending on how many clusters that you have running, or how many nodes that you have running in your environment, things never stay the same. So we started to ask, what is one thing that we can change that is not difficult to do, but will bring the biggest impact? And that's when we came across OpenJ9. And OpenJ9 is a VM built by the IBM Java development team. And it's been tested for decades. They've been using it for a really long time, but they just recently open sourced it. I don't remember the actual date. I think it may have been 2017. And when you go through the page, go through the documentation, they say that it's a VM designed for the cloud. And so we're like, okay, all right, let's hear what they have to say. And so they have some benchmarks that they post on their site. And basically what it is, it's a small application, like a day trading app that is given about 1 gigabyte of memory and sent different types of request loads, and basically just trying to compare different scenarios for that app. They run these tests with OpenJDK8, run it with OpenJ9, the OpenJ9 VM, and then another version of the OpenJ9 VM with some optimization. And the results were actually pretty impressive. What they saw was a 66% reduction in memory footprint and a 40% decrease in startup time. Yeah, that would be bad if we had that. And so we were like, okay, these are pretty good. What happens if we add it to Linkerd? And so this is what we had before, almost hitting about 400 megabytes. And then now we're able to bring this down to about 213. And it was really funny when I was working through this because I didn't believe it. I was like, I must have had something wrong. So I kept on refreshing my tests, and I kept getting the same result. I was like, okay, I guess that's what it is. But this is just changing the VM. We didn't have to tweak anything. We didn't have to do any add any additional parameters to get these values. If you do want to take this even further, the OpenJ9 VM has additional optimization flags that you can configure. My favorite one is this this Xtune virtualized one. Basically, you can tell the VM that, hey, you're running in a cloud environment, so I want you to be able to use threads efficiently. VM does its thing, does its analysis, and it actually does a pretty good job at not using too many threads or not using too much of the CPU. And this saves costs. So if you want to save some money in your cloud environments, turning that on is pretty useful. Okay, so this is Linkerd with a bunch of optimization flags added. We're able to get this down to 172. So still kind of almost at that 200 mark, but we're doing pretty good. This is 172 megabytes per host. That's acceptable for some. And so we continued our quest to look for the one great VM. And then we kind of found GraalVM, and I'm sure you probably have heard other people talking about GraalVM. It's a VM that's aimed at breaking down boundaries between languages, where you can compile everything down to one single kind of bytecode and run it on one VM. And what we were looking for in Graal was the ahead-of-time compilation and also the ability to build native images, because we wanted to be able to run Linkerd without having to have this huge bloated VM running alongside it. And what was interesting about Graal was their closed world assumption, where you can do ahead-of-time compilation and then get a highly optimized version of your application. We started running into issues with this because Linkerd was designed to be pluggable. So pretty much it's just a big application full of dynamic class loading libraries. And so we kind of started to struggle with that a little bit. And so we have a working group with a lot of people from Oracle kind of helping us, figure out how to get Linkerd running with Graal. There's some work already been done where we are able to compile Finagle and Netty with Graal, with some slight code modifications, and we're making a little bit of progress on Linkerd, but this is basically the heart of Linkerd, where we're just loading in a bunch of libraries, and this is kind of like this has been our pain point that has kind of slowed things down, but we're still continuing to work on this, and hopefully we'll get to a place where we can run Linkerd on Graal. If you're interested in joining our working group, we have a mailing list that we use to update people in this working group, or we have our Linkerd Slack channel, or a channel specifically for Graal that you can hop on and ask any questions if you need to. Okay, so we've tweaked everything that we could tweak. We've changed the JVM. What else can we do? Well, we started to think about this a little bit, and we're like, what if we don't use the JVM? Now, I realize that I'm at Scale by the Bay, and this entire conference is pretty much about the JVM. But before you bring out your pitchforks, just let me explain myself. For Linkerd, there are two things that are really important to us. And one is that we are not using too many system resources on your system, and that we're adding the lowest amount of latency when we're proxying your requests, because we want to be able to be transparent. We want you to go into your system and not even think about Linkerd running in your system. So these two requirements are pretty important to us, and we're not kind of discrediting the JVM because it's definitely more than capable of handling high throughput and doing the things that we need to do in these scenarios, but maybe we could do things a little differently. And so that's where Linkerd 2 comes in. With Linkerd 2, we kind of rewrite everything. We rewrite the proxy in Rust. We're able to get actually not pretty good, but very good low memory footprints, and also we're able to get sub-millisecond latencies. And if you want to learn more about Linkerd 2, you can come talk to me after the talk. So what is the current state of Linkerd right now? We officially support OpenJDK with a bunch of JVM flags that we turn on for better performance, lower memory footprint, and we also have OpenJ9 in kind of our arsenal of releases. And we also would really love if you try out OpenJ9, because the more people try it out, the more bugs we find, the more issues we can tackle. We're able to move this from experimental to generally available. And then we're keeping track of work on GraalVM, seeing where that goes. And while that's happening, we're rewriting Linkerd 2 off of the JVM. And this has been pretty expensive for us. It's been using up a lot of our engineering cycles, but we feel like this is probably the right thing to do. And right now, we don't have as much feature parity with Linkerd 1, but we're going to get there. We're just making sure that we are doing things carefully. So the more people try Linkerd 2, the more use cases that you have for us, the more, I guess, development we're going to see on Linkerd 2. So just as a recap, cloud native poses some challenges when you're working with the JVM. The JVM is great. I didn't come here to bash the JVM. It's got a rich ecosystem, and the reason why Buoyant and Linkerd is here is because of that. But we're also making efforts to move off the JVM just to see if our hypothesis is right. And then at the end of the day, this is all implementation details. It doesn't really matter how we get things done. Well, it kind of does, because we're all engineers. But what's most important is that we're building Linkerd, or we're building these these applications to solve real world problems and to make the world a better place, as cliche as that sounds. If you want to stay connected, we're going to be at KubeCon, be giving a lot of talks, a lot of workshops on how to use Linkerd. If you want to join our mailing list, you can do so there. If you want to join our Slack, we're always there to answer your questions. And then my Twitter handle, and then my GitHub handle, and my slides will be available there. And that is my talk. If you have any questions.
Yes. So on Linkerd 2.0, are you far enough down that path to have concluded that it's going to be the path I'm getting on? Works for us?
I think we have a pretty good understanding of where we want to go, and we are kind of going full steam ahead on that. Yeah.
What do you think about
Envoy?
Envoy?
Oh, they're good. They're great. They're great. No, I mean, yeah, Linkerd and Envoy are kind of the same thing. We have our ideas of how we can make the service mesh better, and they have their ideas, and we kind of just learn from each other and see who's going to get there. Yes?
Are there any performance hits that you start moving off hotspot? Specifically interested if you're not memory constrained, would it be better just to stay with the normal configuration of Linkerd, or would it still be better to try out some of these frameworks?
I would say for the OpenJ9 stuff, I think it's really good to try out, even if you don't have some of those strict constraints. But if it ain't broke, don't fix it. If you want to stay on the hotspot VM, that's fine by all of us. But we kind of want to see where the OpenJ9 stuff is going to take us next. So trying that out is pretty useful. Awesome.